This conference will now be recorded. This conference will now be recorded.
Okay, let's get started. Again, today, thank you for joining us on OTDR versus iOLM. These are, everybody knows OTDR. Most of you probably know what iOLM is, but maybe not. But this is Exfo's next generation software for doing OTDR testing. And today we have Tammie. She is actually one of our outside people for S&S Solutions. She takes care of training, customer support, and sales within our area. So many of you may have already worked with her, or this may be the first time. Tammie comes to us from a long history in communication. She was originally a tech for Quest and decided to get out of the field and move into the office a little bit more. And from there, she was a technical sales engineer for Exfo. So she went around teaching people about different technologies and about the Exfo products and getting them set up. And then she's done a few other things before she came to us with her knowledge of the communications industry and what it takes to do good tests and get the results that you want. So without any delay, we'll turn it over to Tammie to take it from there.
Thank you, Charlie. As Charlie said, I have about 20 years in fiber optics, and my most recent is the test and measurement side and sales side. What we're going to do today, we've set up some kind of how-tos, kind of get into some of the features of Exfo's products, work as a technical resource for you guys. Feel free. If you guys have any equipment and you think we would benefit from a topic, like you'd really like to see some webinars featuring certain things that you find important or that you have questions about, feel free to let our teams know, hey, could you guys maybe put a webinar together that, you know, shows this, that, or the other? We love your suggestions. We want to try to get the impact out to you guys. As you all know, Buck has a company that's very customer centric, and you guys are our life force. So today we thought, hey, let's do a quick topic and talk about the differences. When we talk about physical layer testing, OTDR has been the gold standard forever, and it gets us to where we got to go, right? It lets us know the health of the fiber, where our splices are, where our reflective events are, etc. Most manufacturers have reliable and accurate OTDR applications on their test products, but can we mute? There's a lot of feedback right now.
Hello.
Charlie, can we mute? Can you hear me?
I can hear you.
Okay, thank you.
Yeah, I can hear you. I think the issue's gone.
Okay, thank you. So, as I was saying, you know, there's a lot of manufacturers and vendors out there that offer OTDR, and with optics and the evolution of optics, we have very accurate OTDR applications across all manufacturers. What Exfo did was they stepped it up. At the end of the day, the industry, we have people retiring. We have people leaving the industry. We're bringing in new people. Training budgets are cut and slashed, and it really is wheels on the ground. Let's get the testing done. Let's get our repairs and troubleshooting done, and we don't have a lot of time for a lot of training. So what Exfo did, they're on, you know, their whole forecast is, how can we make it easier for everybody? How can we take the training and the learning curve away and make everybody an expert, physical layer tester? And about 10 years ago, they came to market with a product called iOLM. So if you guys are used to the Exfo testers, I'm using an FTB1 box. That's the chassis, and it has a 720C OTDR module sitting in it. And when you go into your toolbox, you're able to access information about the modules that reside in that toolbox, what's active and ready to use. With that module, you'll see what applications are available to that device. So here on the screen, we have iOLM and OTDR. As I was mentioning, iOLM stands for Interactive Optical Link Mapper. OTDR, as we know, requires settings. We set the distance of our span. We set the pulse width that we want to use, and then we set the time in which we want to test. When we go out to do fiber characterization, that information is very important. Fiber characterization is the process in which we define and determine what that span can handle. So when our equipment manufacturers, and we're using the transport equipment, when we're installing that into our network, we have to know that the fiber in which it's going to operate on can handle the requirements of the optics. So we set our range, we set our pulse, we set our duration. And anytime we change these settings, we have to launch another acquisition. Now, for those of you new to OTDR, and for those of you expert OTDR users, bear with me. In the OTDR, we have auto settings. You can set auto, and it's going to go ahead, shoot out a pulse width, and it will automatically tell you. It will find the range. It will give you a generic pulse width that it used, and you determine how long you will run that acquisition. The only time you're going to ever want to use auto is when you want to find the distance of your span. Other than that, you're not giving yourself a real nice comprehensive test. Your pulse width, this is your resolution setting, right? We have 3 nanoseconds now in the industry. Used to be you couldn't go lower than 5 nanoseconds. Nanoseconds are literally the time that pulse is going to be on. That distance the pulse of light comes on, it goes off. It comes on, it goes off. 3 nanoseconds is a baby step along the fiber. The lower your pulse width, the more resolution you have close to the OTDR. The higher your pulse width, the better, it's not even resolution, but the farther you're going to go down your span. A 5 nanosecond pulse width is about 1.5 feet long. A 3 nanosecond pulse width is about 8 inches long, about 3/4 of a foot long. So that gives you an idea. When that pulse goes on, 3 nanoseconds, we're only shooting light about 8 inches. So you can imagine it's finding all these events close up. What we run into, though, the lower the pulse width, the less energy it's going to have to get down to the end of the fiber. So when we're doing a characterization test, we're probably going to be changing our pulse width. And every time we do that, we're sending out another acquisition for however long we've determined to shoot one trace. So in characterization, it can be a very manual process. If you have a nice, decent 60-mile span, you may have to do 3, 4, 5 acquisitions to really see everything along your span. All the reflective events, all the splicing events. If you have an issue, you're going to probably do the same amount of acquisitions from the other side to create some bidirectional splices. So you can see it can take a while. If you're doing a 1.5 minutes and you have to do 5 of those, you're in it for 2, 3, 4 minutes. Again, it's just what we knew. The OTDR application's perfect for troubleshooting. We got red lights on in the pop. Our equipment's alarming. We have a cut in the field. We're going to take that OTDR, we're going to plug it in, and it's going to immediately show us where our fault is. Great troubleshooting tool, necessary for characterization. Again, it's all we had. It's the eyes of our fiber. Lets us know the health of the fiber. When running OTDR, you really do yourself a favor, right? You want to run both wavelengths. And again, there's time involved in doing that. You can see here's just a sample trace. And again, In the effort for timeliness, we're really just kind of doing a higher level overview on OTDR traces and using the two applications. So immediately you get an event table. So once I launch my acquisition, my tab's on top, my OTDR tab sets up my my launch, my acquisition. And then I have an events tab where it's really going to give me a graphical view of every place it's measured loss or an event. Sometimes it's a gainer. And then we have a summary table, which gives us all the pertinent information on each event. Gives us the distance. It gives us the loss. If there's reflectance, it shows us the reflectance. And then it gives us a cumulative distance. Again, if you guys have been using your OTDR, this is very, very familiar. You can go into the measure summary, and if you want to, define those cursors and bring them in and really explode and zoom in on an event, you have that ability. And then we have a full summary table. This one at 1550 passed. It did not pass for 1310. All information we need to determine, are we going to shoot another trace? Is there some remediation work we can make right now so we can get past results? It's all right there for us to see and make our decisions. Again, most people that operate OTDR or have for a long time, they can see what the graph is looking at. And I've been in the field with guys that are like, oh yeah, we've got a really bad splice right there at number 7. And you're like, what? How can you see that? Their eyes are so trained. You can always go in and, zoom into an event, really blow it up and see that stuff. This is OTDR. This is OTDR in a nutshell. OTDR is really great for characterization and troubleshooting. Real-time fault location. For those who are newer to the field and they're like, what the heck does this all mean? I don't even understand. What's my pulse width? They have to monkey with all this stuff. Again, Expo came out with iOLM. And this it's perfected on all the time. Before they make an update, I can honestly tell you they do 40 to 50,000 acquisitions. They test it to see if it is consistent in its results. Sometimes people that have used it have said, you know what, I did one shot, it said this, I did another shot, it did this. If you find anomalies or inconsistencies, it's good for you, not incumbent upon you, but there's a team at Expo that likes to hear user experience. If there's something that you think would make sense or you'd like to see a change, feel free to always say that, because remember, they get ideas, they put it out there, they try it, but until the field's using it, sometimes we don't really know how effective it is. So in 10 years, they've perfected this program. This is OTDR that's automated. This is OTDR that has intelligence. So there's algorithms built in to this program. And again, it's a separate application that works like OTDR. We don't want to ever confuse it and say it changes OTDR. As users, you guys have the ability to have iOLM and OTDR on your machine. So you can have both applications. Some people love the iOLM. They just have that. Some people, OTDR is all they know. That's what they're comfortable with. They don't want to see this hocus pocus. So again, user preference. iOLM requires a launch fiber. Have to have a launch fiber. Because of the algorithms that are built into this software, it needs as much information as it can have so it makes the determination as it does the characterization. And what iOLM is doing is, as we saw in OTDR, we adjusted pulse width. One pulse width, one acquisition. Change the pulse width, another acquisition. What iOLM does It has built-in, it's doing multiple multiple pulse widths and running multiple acquisitions. This is the setup screen. I don't have a range dial or a distance dial. I don't have a pulse width dial, and I don't have a time dial. It has intelligence built in, and it's going to do a one and done test result for you. You tell it, your fiber type. It wants to know, okay, we're doing 9 micron. I have a quad OTDR unit in this FTB box that allows me to do multi-mode as well. So you determine your core size and fiber type. You tell it, I want to do both wavelengths, and that's just mandatory. And for those that don't know, by choosing both wavelengths, you're allowing your OTDR and iOLM to help you with bend identification. You need both wavelengths to identify a bend. You put a launch fiber on. You tell it, okay, I'm going to be using this launch fiber. And now it wants to know, okay, what's the measurement? If you're using a Expo launch bag, the minimum is 150 meters. If you don't know, you plug in your launch bag into your single mode or multi-mode port, whatever fiber you're using, and you hit calibrate, and it's going to measure it for you. Once that's done, you hit start. It's that easy. If you're trying to qualify the connector at the very end of your span, you might put on a receive fiber. Tell iOLM, hey, I'm going to use this as a receive fiber. Measure it for me. Great. Here's my measurement. I'm going to plug it in at the end of my span. I'm good to go. And then I'm going to hit start. Now it's going to go out. And with the information I've given it right there, now it wants to, we're going to just here, we'll look at the sample. Now it's going to run a measurement. This is a failed measurement. And you're going to get a result like this. So this obviously looks different than your OTDR result. We've changed our jargon even. In OTDR, we have events, and we have a summary table, and we have an event table. Well, in iOLM, we created elements. These are the elements of the span. And each time, as we saw in the OTDR, we saw a red marker for every event it measured. It gave us a box. It gave us an icon. It has a measurement. It's letting me know up here along this line, this is the view that I'm seeing on this span. I can hit the arrow, and I can go and go and go. Based on the definitions and the threshold values, it comes up with an automatic icon. Element 5 is a splice. If we go through, let's see where it failed. I know it failed at 1310 because I think this is the same fiber. I'm not sure. I'll have to look at that. Well, obviously it's right here. Duh. So the link loss value at 1310 nanometers is below. It did not meet or exceed the threshold defined in the test, although it did at 1550. If I hit, again, I'm at link view. I'm not at event summary. I'm at link view. I can hit one of these icons. I'm going to look at element 17. I get my summary right here. Hey, based on what I know, I've determined that one is a splice. I saw no reflectance, no measurable reflectance. I'm calling it a splice. It did have a loss value, and it's reported this. This is kind of like your summary table, your event view, but we call them elements. I can go into the element tab, and it's going to call out all my elements. And what's interesting is, let's just say you have an APC connected event, right? You know that at this distance, there's a patch panel. You know this is not a splice. There's a physical connection. Well, based on what iOLM knows in its smarts, it didn't see any reflection. So by default, it called it a non-reflective element or a splice. Well, maybe I know that I have a connector Well, now I can say, you know what? I have an APC connector. I have a reflectance value of better than 80. Your OTDR sees anything better than 80, or what do we set at 80, as no reflectance. I can now call it out and say, no, I know that's a connectorized event. So I'm going to call out and change the properties of this element because you know your network. iOLM is a marvelous application and tool when I want to characterize my network. It's going to go faster than if I use OTDR, only because it's a one and done. Based on the length and everything it sees and the brain power it needs to use to get us our results, it's going to run for an undefined amount of time. I can't go in and say, hey, run that for a minute and a half, please, because it's telling you, hey, let me do it. Take your hands off the bike. I can do this. So it's going to run. It's running those multiple acquisitions back and forth, back and forth, back and forth. And it says, okay, I think I got it. This is what I saw. And it will come up. It doesn't run double time. It's not like you're going to use iOLM and it's going to have to run 16 minutes. It's very, very quick, but you don't have control of the time. So what's the disadvantage of using iOLM? Well, let's say I got, Christmas alarms going off in the pop or the head end, and now I know I have a fault out in the field. Because iOLM thinks on its own, it's not going to be the best tool for me to say, hey, fault locate. Because if I have a cut in the field, I need to get, wheeled down. We need to get out and find out where it is and start our remediation work. And iOLM is thinking. He's like, I got to think about this. I'm going to run multiple, here's my end of fiber. So what Expo did, that was a limitation of using iOLM, is it wasn't the best troubleshooting tool. It's a phenomenal fiber characterization tool, but not an ideal troubleshooting tool. So what they did is they threw in a real-time OTDR function. So if for some reason I need to find out, I got to find out if we have a breakout there and where it is, you can go in and do a real-time OTDR where it's really just going to run it and say, oh, look, here's that noise floor. It's 27 miles out. Go get it. Those are the basic differences. Now, again, you can imagine iOLM came out about 10 years ago, and it's perfected upon all the time. And sometimes if you're in the business of providing results, you're a contractor and you need to do characterization of a fiber span, and your customer really only knows OTDR and they don't want these fancy, pretty, blinking, flashy test results. They want to see the graph. They really want to see that you've done it. I can tell you that a lot of service providers, Verizon, Google, AT&T, CenturyLink, Lumen, Quest, whoever they are, they're now accepting the graphical interface, this GUI. Now, maybe you want to see the OTDR trace. You're able to go in your settings and say, listen, I really need to see that graph. I mean, I trust this. I know it's working, but I'm just used to seeing my results in a graph, a graphical view. You're able to have that result. The only difference is with every OTDR trace, you're given information, right? This was the pulse width. This is how long we did it. That was the distance. Because this used variable pulse widths and it did multiple acquisitions, you're really only going to get a trace or a graph that is an interpretation of these results. So you're not going to see a pulse width. You're just going to see a graphical view. That's helped people too. So at the end of the day, it just becomes preference. What do you like to do? This, great for the new guy, right? He doesn't have to worry about interpreting a graph, get my A and B cursor up there, really zoom in on an event. Nope. This is the one and done. Hey, you're an expert a fiber characterizer. Those are the main differences. Now, we have a little time. And if anybody has any questions right now, please ask, because I don't want to go over something that you might want some attention drawn to. Okay. I have the chat window up, so if questions come up, please feel free to use that chat function and we'll address them. There are certain things you can do with iOLM, even though it thinks for itself and it gives you its best calculation and result. You can make changes. Like I said, this is your setup screen, right? Here's my launch fiber. This is how much it is. I'm going to use a receive fiber. This is how long it is. The end. I hit start. But maybe you need to adjust thresholds. Maybe you need to set pass-fail thresholds. Well, if my splice exceeds 0.02 dB, I want it to fail. If my reflection is less than minus 42, I want it to fail. So we go in to test configuration. Oh, I'm sorry. Let's go into test configuration. Please see in the test configuration menu, there are canned configurations, for lack of a better word here. Point-to-point, two connectors, custom pass-fail thresholds. Okay, well, let's say I have a lot of short events. Let's say I'm in a data center and everything's about 3 to 10 meters away from each other. I'm able to say, you know what, hey, iOLM, I'm going to do some short link close events. That way, I'm telling iOLM, be prepared for the smaller pulse widths. I want you to find a bunch of these short events, and it will. Let's say I'm shooting through a pond splitter, and I've got cascading splitters. I'm able to, here at the configuration page, to give iOLM more to work with. Hey, make sure you're really boosted up for some splitters in the network. Now, let's say you just plug it in and go, and you forget to go in on the test configuration. These are aids in which to set for iOLM to be even more efficient. Does that mean that if you don't set these up, you're not going to get good results? No. But let's just say you did a generic point-to-point, you told it to go without realizing, oh, crud, I'm doing a Comcast PON environment, topology, and I forgot to tell iOLM. More than likely, iOLM is going to see those splitters. It's going to be able to understand its results. But if you look at it and you're like, oh, that's kind of wanky, I'm not really sure I'm confident with what it saw out there, you can come into your test configuration and, like I said, give iOLM a little bit more to work with. If for some reason like this custom pass-fail thresholds, once I've selected it, now I can go in and I can modify my thresholds. I would warn you, and we'll go back here, make a copy, point-to-point. These are some of the stuff in here is default, and let's just say, we'll go to default. Just say you've made some changes and you're like, oh, crud, I kind of want to go back to the way it was. Do a simple duplicate. It will duplicate the whole event, the whole configuration. But now you can modify that without compromising the integrity of the setup in one of these. Again, all of them have custom pass-fail thresholds. You get to go in and determine what your thresholds are. So you can rename it, name it whatever you want. Port. Let's just say this is like a favorite, you're making a template. Hey, Bill, when you grab the OTDR and you use iOLM, make sure you've dialed in the configuration that says Verizon. Because in that configuration, we've set all the custom parameters and thresholds for when we characterize their fiber span. And this one will say, oh, well, we always test single mode. It's not a multi-mode. We want both wavelengths. And we don't, we have no opti mode on this setting in particular. Then we go into, link definition. Now, let's say I know it's pawn. I have some splitters. What's your stage 1? This is for cascading. Well, I have a 1x8, and then beyond the 1x8, I have to look at, 1x4s. Oh, okay. So now it's already, you're telling iOLM, look for these splitters, and based on my splitter profile, determine the loss associated with those. And then I go into my pass-fail thresholds, and I'm able to customize those. Apply thresholds to element. If I uncheck that, if I don't, I'm probably not going to have any pass or fail thresholds. I do have a maximum link ORL, link length, or I can apply specific thresholds to each element. Save it, and now you've created a template in your iOLM module in that software application. So again, we try to make this easier for all the testers. Time is money, money is time. We don't want you guys so overwhelmed with the minutia of setting things up. So you can do this one and done, save the template, and when the next guy comes along, all he has to do is hit it and say, aha, let's go. I'm going to hit it. Here's Verizon's configuration. I know all the thresholds have been set. I have a pass-fail result, and I can do this. Are there any questions at all about iOLM, OTDR, some of the advanced functions when you're dealing with the Expo toolbox or any of these modules? You're able to go in under user preferences and determine, do you want to use kilometers, kilofeet, meters, or feet. Expo's been great, and I can only speak on Expo. I haven't used any of the other manufacturers, but they're really great at the consistency and cohesion of their interfaces. If you're physical layer tester and OTDR, but your buddy's Ethernet, you guys have the same look, the same GUI, based on the testing you're doing. It's always got, it's tabbed, and we have a right menu bar, user preferences, test configuration. They try to keep the language the same. So it just try to make your guys easier. I do have a question. When I open iOLM and look at the link view on a previously saved trace, how do I bring up the OTDR view? So when you're in iOLM, you don't see the trace view until you've saved it as a report. So you've saved a PDF of the unit. Let's do one really quick. Well, I'm looking at samples. So although you're not going to see a graph, an OTDR graph on the iOLM screen under link view, let's see, do I still have my file up? Let's do. Fiber 1. So, hold on, you guys. All right. So, under user preferences, I say, you know what? I really want to see a Belcore file on save. That is going to be my OTDR trace view. And then under report, I want to see my OTDR graph and my fiber section. And I say apply. And I say okay. And then I tell this to, hey, make a report of this, please. Fiber 1, and it's going to now be a PDF. Now that it's a PDF. Also, I've had people ask me, they're like, I have this iOLM trace in my in my Explorer and I'm trying to open it and I can't read it because it's in a .iolm folder or file. Understand when you're looking at the .trcs, which is the Expo native format for OTDR traces, or you're looking at an iOLM view, you must be in the application to view those. This application is a reader, but once you hit the report button, you've actually saved it as a PDF. So I can go, let's see if I can look at it here. I haven't done this for a long time. Documents, can I do all files? No, I didn't think so. So if I'm in iOLM, I can look at iOLM results. If I'm not in iOLM, I can only look at the PDFs. So I'll go to my little Fiber Explorer or File Explorer, and I think this is where we saved it, right here, recent files, Fiber 1. This is my report. There's my OTDR graph. So it became an interpretation of my link view. Does that answer your question? Perfect. Is there anything else that has been a problem for you or you don't understand? With this pandemic we've had to deal with for a good portion of this year, it has limited our ability to do a physical outreach. My territory is California and Nevada, and we all know, and I live in Southern Oregon, so we all know that state to state the restrictions differ. And I don't have the flexibility to just go in and see a lot of my customers. Some of my customers we will have no visitors at our sites. We're not allowed to visit with people. We cannot talk to our vendors. A lot of our partners are work from home. And even some of our manufacturers look, our company said no traveling. We're not traveling till the end of the year. We're not traveling until the end of 2021. So because our hands are tied and we can't always get out to see you guys and really come out and do demonstrations, showing you guys the latest and greatest, we're relying heavily on our digital footprint and really reaching out to you guys digitally and not being redundant or excessive or, overwhelming. But you guys are the ones that use this equipment on a daily. And it is our job to make sure you guys are working with your equipment confidently and that you have a full understanding, because these are powerful tools. In my experience, when I was a technician at Quest or CenturyLink, we used the OTDR, a big fat Expo, FTB 500. This is the clunker. This is the doorstop. It's huge. And it holds big modules, and it was the fiber characterization tool for its time. And we pulled it out of the cupboard because all the red lights were on in our inside plant, in our office. And it was like, okay, grab that big Expo box, take it over to this patch panel, plug it in, let's find out where the break is. Hit start. Oh, it looks like it's 127 kilometers out there. Okay. All right. Bam. That's all we use this box for. This huge box. We only used it to find out there was cable cut. Expo has gone and dropped their platforms down to, little sizes. These are handheld. There's various forms of the platforms. If you're using a Max tester or using one of the fancier FTB ones, your functionality, accuracy, and confidence should be the same. And they do a whole lot of stuff. Right now, Charlie and we're presenting you this in GoToMeeting on the FTB box. What you see on my screen is the desktop of your FTB platform. And we were able to throw in GoToMeeting. We set up software on here. I'm going to close out all the windows and give you an idea. This is the desktop of an FTB1. It works just like your PC, and we're hosting a webinar from the box. You know, I'm kind of remote controlled in here. I can VNC it. I can throw down TeamViewer or another third-party remote control software, and I have full access. We've really, Expo and the industry at large has really tried to make this as easy as possible. But sometimes real easy can be intimidating because it's too easy. You feel you're missing stuff. So if there's any takeaway from this webinar, we're here for you guys. If there's a question of user ability or operation functionality on your machines, I don't care if you're using an FTB 200. If you have a problem, give us a call. We've committed and promised you guys, you're our customer. We are your tech support. We're your customer service center. We're your trainers, and we are your resource. So if there are no more questions, I hope you guys got a little something out of it. We try to make it brief and not too overwhelming, and we welcome your ideas for any future topics that will help you in your day-to-day. And with that, I say thank you for your participation, and I hope you guys have a wonderful week.
Thank you, Tammie. At this point, looks like we have one other question that came in. There's one other question that came in. It says, the short link close event test configure was a great tip. I'll make some custom configs. Thanks. It's more of a comment than a question. Sorry about that. But if anybody, like she said, has any questions, please feel free to reach out to Tammie or myself or Buck. Many of you know Buck. Or if you have a particular person that you work with here at S&S Solutions, they'd be happy to help you in answering any questions. But that's the end, so we'll let everybody go. Have a wonderful day.
Okay, Chad has a question. Oh. Yes, Chad, you should have a Windows 10 update. For those of you still on the call, good question. My FTB is running the Windows 8, prior software. Is there an update? I would remind everybody on occasion, about every 6 months, go out to the software update, usually an icon shortcut in the top left corner of your desktop on the FTB1, and look for updates. There's firmware updates, there's application updates, and there's chassis updates that sit out there. It will take you to the Expo website, and with a short registration, go out to support. I think it says downloads, look for your unit, look for your OTDR module, and see what updates are available. When you're using an FTB format, you can go in and it will automatically go out and look for it online when you're online. Or because it goes online, you can do an automated search. If you're using a Max environment, the updates are different. It comes out as a full image, and it's easier if you just download it from the website onto a USB drive and then plug that USB drive into your Max tester. And again, if you guys need information on how to do that, let me know and I'll get that to you. My information, Cody or Charlie, you can do that.
Okay. There's actually two questions here. I'll get to the contact information. There's one other question. Oh. What is the length of the launch cable one should use when using iOLM? Max lengths are 15 kilometers.
Okay. So the beautiful thing about iOLM is there's a question mark next to the launch fiber box before you hit calibrate. There's a question mark, and it will tell you. Expo does 150 meter canvas single mode fiber launch bags. They're just 150 meters long, but it will also let you know that the minimum length you can use is 15 meters. So if you have a 15 meter jumper cable, that will suffice as a launch cable. And the maximum, I think, is 1 kilometer. But that question mark in the iOLM program or the application will let you know. In fact, if you have a minute, we'll launch it really quick and I'll show you exactly what it says.
And while she's doing that, I'll go ahead and give our information. So if you want to reach Tammie, you can call her at 480-737-9136. You can also, her email is Tammie, Tammie, at ssolutions.us.com. My information, my email is the same as Tammie's, but instead of Tammie, it's Charlie at ssolutions.us.com. So that's CHARLIE. And my phone number is 480-962-4849, extension 1. And I'll go ahead and drop this into the chat for everyone.
I'm going to put this in kilometers, because that's pretty much a standard. So when I go here, they've changed this a little bit, but based on the expected loss of your link, let's say I don't expect more than 15 dB, it's going to tell me that my launch fiber at a minimum needs to be 15, and I correct myself, at a maximum 5 kilometers. So again, you know, it's preference, but you'll see through a lot of these, let's go 10 dB, 15 meters, 5 kilometers. So it gives you a minimum and a maximum based on your expected loss. If you're unknown, it's like, well, I'm characterizing this. I don't know what my expected loss is. Again, it's going to be 15 meters and 5K. All right, guys. Well, I really thank you for your questions, your comments, and we look forward to hearing from you. And again, if there's anything we can do for you, that's what we're here for. Please don't hesitate to reach out.
Thank you, everyone. And Tammie's information is up now in the chat if you want to grab that real quick. So if there's nothing else, we will let you all have a good day.